All right, let's see if I can try a slightly different approach here. Let's draw a picture. So here's the wall, and this string that comes out goes around a pulley before it comes back to this block that moves along the surface here. And then right here is that movable pulley, which I'll just call that pulley there. And let's do this. Let's say that the string that goes all the way out and around has a length of L. And the part of the string that goes from the wall out to the pulley, let's call that Y. Maybe I should call it X. X sub P for the distance to the pulley. So I use the P. And of course, then it wraps around so that this distance here would be, I guess, L minus XP. And then let's call this distance going to the block X sub B. And so I'm hoping you can kind of see in this picture then X sub B plus L minus X sub P here equals X sub P. And if we then rearrange this, and this is this factor of 2, and bring this over to here, 2xp equals to then, I'll just put the L first, plus xb. And of course, if we talk now about a change, any kind of change, this L doesn't change, but now we see that as there is a change in x sub b changes is twice that of x sub p. Maybe you see it better in the math if I take the derivative with respect to time. And so the derivative of the L is the 0. And then we have x sub b over dt, and then the 2, and then x sub p over dt. And then this is the rate at which b is changing. So this would be what I would call the velocity of that block. And then this is 2 times, and this is x sub p. So this is the velocity of the pulley. And so there's your 2-to-1 ratio. And so maybe you see it better here in the math than the way I tried to explain before. In fact, carrying this a little bit further then, maybe the easy step then is to say then that this, if the velocity of the pulley is the same as this block going down, which I think they call this block number 2 and this block number 1. I can't really tell in the photograph here. But if that's the case, then I would say velocity of the pulley is the same as block number 2, so velocity of number 2. And then, of course, what I called the velocity of this block is what I think they call velocity number 1, and there's your 2-to-1 ratio that you're asking about. I hope that helps.